Okay, Grok and Elon Musk, just can you type? DeepSeek was the top downloaded app on iStore. So it is able to create this object from code. Is that the
Yeah.
case? NVIDIA's stock price going down 600 billion. I mean, I used OpenAI for some query, and it fascinated me that it gave wrong answers, but it gave wrong answers in a very confident tone, as if it's getting the right answer. Hello, everyone. Welcome to a series of talks on AI. We call this AI Roundtable. This week was a huge and eventful week in the world of AI because the entire world, the ground beneath us sort of shook. And the reason it shook was the earthquake of 3.8 Richter scale. But the actual earthquake happened in the capital markets, wherein people were taken aback by DeepSeek and its aftermath. So, and we will take a look as to what DeepSeek is in this, talk that we have, and you'll have some understanding as to the innovation that DeepSeek has done on top of the innovation that was done in OpenAI and other research labs around the world. So, what do we have as part of the news this time?
Today's content covers mostly around DeepSeek because that's big in the news this week. Since yesterday, everyone is talking about DeepSeek, how it's better than ChatGPT, how NVIDIA prices dropped, and all of that. So I think first things first, everyone wants to know what happened to NVIDIA stock. Like it lost around $600 billion. So I think we'll go first towards that. Then also an interesting thing, DeepSeek says that they got a DOS cyber attack. So we'll move on to that. And after that, we'll go to the core of the problem or the topic, elephant in the room, the R1 model. So yeah.
So in terms of like NVIDIA's stock price going down 600 billion. So just to give context, NVIDIA does about $60 billion of revenue. It must have crossed like 100 billion this year, and the net worth of the company is 50x of the revenue. So usually in technology companies, for example, Twitter used to do about $2.5 billion of revenue and was worth 25 billion to 40 billion, right? It's usually 10x of revenue or usually 20 times earnings or 10x of revenue. It's like usual norm for technology companies with high growth potential. So usual companies which are let's say companies which do not have high growth potential, it's usually 2x revenue. For example, Ford, it's like they do 50 billion and the company is not even worth 50 billion. So, given that to be the case, that gives you a general sense as to how companies are valued. NVIDIA, which has sort of a monopoly in making these graphical processing units, which are different from CPUs, and they get components from 35,000 different vendors, as a result of which they are a monopoly in this space. So their company was valued at around 3.4 billion and it dropped 600 billion in one day with the news that DeepSeek has essentially executed a model which has reached the top of let's say the App Store charts within a week of its release. And the big news is they've only spent about $5 to $6 million to execute the whole thing. Nobody can confirm that to be true, but that is the reason people were taken aback as to uh, why NVIDIA, the people were reevaluating the fact that the pricing power that NVIDIA has is not really what's the paper on which it is written on. So that's why there is a lot of negative reaction on the aftermath of DeepSeek. What do you guys think based on what you understand?
I I believe why there is such a huge let's say a drop in value is because unlike nowadays anyone can buy a stock, right? You don't have to have a specialized account or like a trading account. So like common people really do buy a lot of these stocks. So I believe that that's one of the reasons, because when this news came out, a lot of people you know went through the hype and just started dropping shares, and as a result the company lost 600 billion. That's
Abhishek,
my
you
take.
have something you wanna? What do you think of it? Because the I would people want people in your cohort to understand uh, what to make of it. So, what would you tell your friends as to what happened in NVIDIA?
So the basis of the commotion I feel is that all the big tech companies who are in the forefront of this AI revolution that is happening, like Meta's Mark Zuckerberg just announced that they are going to be investing $65 billion this year for advancing in the AI technologies. And then there's also OpenAI with Oracle and SoftBank, who are backed by the White House with a whooping $500 billion uh, year back
$500 billion investment.
investment. Yes, so these are really huge numbers, and they say that the only thing that is stopping AI revolution right now from going forward is money and time. And here comes China with DeepSeek R1 with minimal resources, both in time, just 2-3 years in their and like 2-3 years in their advancement, and with as allegedly like $6 million worth of investment, and they are already advancing than the present competitors that are there in the field. Also, I heard somebody from Meta saying that DeepSeek AI is more advanced than the current model of Llama. Also, the next model, which they are going to be announcing soon. So that has caused a really huge commotion in the field. And I feel people really wanted a very big, what do you say, page turner in this entire paradigm, because it was always OpenAI and Facebook. So having a new challenger in the field is getting their hypes really, and like it's hyping them up.
Yeah. So the in terms of, let's say, how experts think about it, like even though both of your points are valid, that there is a sense of optimism in terms of AI, and a lot of people are putting a lot of money to work. So when they see, so the thing that you have to remember, the central gist of the entire conversation that underpins the events of yesterday is that OpenAI accomplished what it accomplished on the backs of $20 billion of investment over a course of 5 to 10 years. And DeepSeek did that in 2 years with, they say 5 million. It's probably like 100 million, like 10 times of that, 10 to 20 times of that, because even by their own disclosure, they say 5 million is the cost of this run, and it doesn't take into account 200 employees, which are listed as part of DeepSeek, the employee salary for the last 2 years. That is not taken into account. The researchers who are researching on this topic, who have lent their time and effort, it doesn't take that into account. So just this compute time is 5 million, which is astonishingly low compared to the usual compute time. So that is what, rippled the entire markets. So, but I don't think it's that big of a. I think it's a big deal. I was having this conversation with somebody else, and I said, this is not a big deal because the paper on which DeepSeek has written its own paper is based on an OpenAI scientist, John Schulman. John Schulman's RL model is still, one of the work that he did as part of the OpenAI team is still a pioneering work, and the DeepSeek acknowledges that. But having said that, you can say the same analogy with Google and OpenAI, right? So Google people invented attention mechanism. They wrote the paper. Just because they wrote the paper doesn't mean they got the market. OpenAI captured the market, even though they implemented it better. So it might so be the case that DeepSeek did not invent all this technology, but they just executed in a manner in which they got distribution immediately, right? So OpenAI did to Google what DeepSeek is doing to OpenAI. Whether they'll execute, that is totally dependent. And Google also has, I think, not so good competent C, let's say not so competent CEO. So the only difference here is, Sam Altman is a very, uh, he was head of Y Combinator, so he's a very shrewd player, so to speak, as opposed to Sundar Pichai, who doesn't have any startup experience, never has founded any companies. So his reaction, that might be the difference between how OpenAI reacts to DeepSeek as opposed to how Google reacted to OpenAI. So this is still an opening gambit. So there's a long way to go, and we don't know for certain as to who's the clear victor at this point. But based on the in market capitalization is totally dependent on the valuation of the company, and the valuation of the company is dependent on the pricing power of the company, and pricing power depends on the competitive advantage you have against your competitors, and that comes from distribution, a number of customers you have. And DeepSeek has done all the right things. In 1 week, they are on top of Play Store. They are able to capture people's imagination, and people are downloading and playing with it. Whether they will retain all these users, and all these users end up paying for them over a course of next 1 year, that needs to be seen. And the fact that they're a Chinese company and there are a lot of data issues related to that, I think Andrew Ng had a great tweet yesterday. If you can open Andrew Ng's tweet, he basically said the fact that they, the fact that all the action is in the application layer, and the DeepSeek has essentially shown the fact that the competition at the language model level is so intense to a point, the safe bet is only in the application layer. He says that today's DeepSeek sell-off is, and this tweet was viewed by close to 500,000 people. So today's DeepSeek sell-off in the stock market attributed to DeepSeek V3 disrupting the tech ecosystem is another sign that application layer is the great place to be. The foundation model layer being hyper competitive is great for people building applications. So basically what he's saying is don't take the risk of building language models. Let some big players do the language models. You focus on your customers and make sure you keep the customers happy. As a result, Perplexity today has remained totally unchanged. I mean, if R1 model came along, all they did was plugged in R1 model into their user interface, and they're good to go. So they're not affected regardless of who the end customer is. So I think this is still a long way to go, but this is a good wake-up call, which basically says like, if you can assemble a team of 200 people, they can probably beat OpenAI. And OpenAI is like 1,000 people, so it's not that big a deal. Any
So
other thought?
does the size of the company like enable them to make decisions faster and have like rapid development and deployment of these models, or how does that work?
I think I won't consider myself an expert to give edicts on these kinds of issues. The size of the company and the culture helps. The smaller the size of the company, faster will be the decision making. Or let's say the more horizontal the company, faster will be the decision making, provided the leader of the company can facilitate that diffusion of decision making. So, Google is a very vertical, hierarchical company led by an MBA. So that's the real issue here. I mean, Google's incompetence versus OpenAI's competence, and OpenAI might turn out that they are just as incompetent as Google. So we'll see. But hopefully they won't be, because I don't think, if you look at Sam Altman's tweet on the same issue, he said like, yeah, they've done a great job, but don't count us out. We'll just do as good a job as we did previously.
So yeah, this is what I was talking about. So some of the reasons why users aren't able to register themselves on DeepSeek is because of this. So they haven't given us a clear idea of what exactly hit them, but they say it's a DOS kind of an attack. So they say it was a very large scale attack, and that's the reason why a lot of existing users can use it, but they're not taking new registrations so far. So that's also one. This all happened yesterday. This all happened in like a chain of reactions of all of this. So yeah.
I think that's probably, I mean, there are so many people. What is classified as a DDO, a denial of service attack, is, if there are like, close to like 10 million or 50 million people log in all of a sudden onto a platform, I don't know if that the definition of denial of service is close to a lot of people logging in at the same time. Probably in a week's time, this will just cool off, and they'll also figure out their security issues.
Also,
But I
like
mean, I don't.
if you like
Yeah,
try to if you use DeepSeek just as you would ChatGPT, there's a lot of times that DeepSeek crashes. Like it says resources aren't available, or just doesn't give you an answer. So I think that's also one of the reasons. Since a lot of people are using it because of the hype. Everyone wants to check this out and try out the R1 model. Yeah.
yeah. I mean, it might so be the case that in a week's time, this will all sort itself out. Also, OpenAI's valuation can come down. I mean, they're valued at 150 billion, but they're already doing close to 5-6 billion in revenue. So if you think about them, they're like 30x revenue, 30 or 20x, which is not as bad as 50x, but it's definitely worse than some of the tech companies in terms of higher valuation. So we'll see how that goes. It's a private market; they won't get affected. What else did we have? I think a lot of people are Googling this weekend, all about people Googling about this particular model, and everybody is trying to understand the math behind it and some of the use cases that this has. So, can we run through some of the use cases? Probably, Gunawardhan, you can probably take up all the use cases. Which this is the first use case. So we are taking tweets from one of the Twitter users, Poonam Soni, and her opening title was "Goodbye ChatGPT." I mean, she has provocative ways by which we can go to the Twitter account and directly check. So 13 jaw-dropping updates you need to know. Don't miss the fifth one. So let's go ahead. And it basically says China's, I mean, there's no Trump said it's a wake up call. Are
I
these
think
the 13 ones? I think we opened some of the tweet here. This is not is this the same tweet?
these are the use cases.
Yeah. Can we play this? So it is able to create this object from code. Is that the
Yeah.
case?
Create it and even run it. So you can run it in the browser itself. So that is what they're doing. Just like GPT's canvas where you can run the code. This is like that.
Yeah, I think this is a very interesting use case for education companies, like people who want to demonstrate some mathematical object on the go. This is great. So another big news that the second image points to is the fact that DeepSeek was the uh, top downloaded app on iStore. I think it's also in the top 10 or 20 in Android store. I don't know the rating, but it's in the top. A lot of people are downloading it and checking it. What is fascinating or funny is that Threads is at number 3, which boggles my mind. Like people are using that. That's what is
It is.
surprising about this
I
screen.
just checked this and it is giving DeepSeek as the number one
Number one
downloaded
in
app.
Android. Oh, that's great. That's great. Yeah. So what was fascinating, I mean, I laughed. I mean, a lot of the people were laughing at Threads too. I didn't realize Threads is that famous. I thought nobody used Threads and it's still at number 3. So, good going, Meta. So let's look at third use case. So DeepSeek R1 1.5 can run on virtually any hardware. What's 4 times 245?
Still thinking.
Just
19.
pause this. Not now. I mean, when it was giving the thinking process. One of the things that I've been told about this model is the fact that it gives you chain of thought process of thinking, meaning like it breaks down the problem into smaller chunks and it tells you how it is doing it so that you can see the machine in action. Okay, so I need to figure out the best way to proceed. Just pause.
So this
They
is the
mentioned
famous part.
being Apollo, the AI chat assistant, so I should keep things friendly and informative. First, I'll calculate 4 multiplied by 245. Let me do that. 245 times 4 is 980. That seems straightforward. I should make sure to present the answer clearly. I should also consider if the user needs more complex. Oh, it's telling what it's thinking. I don't know if that is useful in all scenarios, but I think it's a good add-on. You can just play it.
Maybe I think in this scenario it is not useful. Maybe when it's solving a slightly more complex mathematical problem, it'll probably help us understand how it got to the result rather than just looking at the result.
Yeah, probably.
With respect to the chain of thought, I think there's another video that I might explain it more clearly if I can play that.
Yeah, you can
R1
just
model uses the chain of thought prompting approach, which basically encourages the A1 model to break down the reasoning into simple to understand steps. This isn't new, but DeepSeek R1 does this really well. So let's use this simple math
So this is not a really complex one, but kind of those tricky questions, I guess.
problem as an
yeah.
example. The
Let's
first part here is the problem to solve, and the second is the prompt that I've added to show its chain of thought. So that's specifically, let's solve this step by step. For each step, explain your thinking and show your calculations. So hitting enter, you can see DeepSeek thinking and reasoning with itself, and this is what makes R1 different. It transparently reasons through each step individually and figures it out in the same response in real time. Whereas GPT can often be sort of clinical and political, I found DeepSeek R1 to be direct, but also great at showing you the reasoning, and you can also extract the reasoning and send it to other AI models too, something that's unique to DeepSeek R1. The other cool thing is how DeepSeek R1 solves hallucinations. So hallucinations is a term to describe when
So with respect to hallucinations, I think like in the earlier days when ChatGPT was a thing initially, it used to hallucinate a lot. And what I mean by that is it used to give wrong results repeatedly, especially when you are using the same chat window for an extended period of time. Let's suppose I was asking it to write a code and it's giving me the wrong code and I ask it to make changes. It won't make the changes. It'll just, reiterate the same code. That was one of the issues that I used to face. I think it's still an issue, but not quite as much. But yeah, I think DeepSeek kind of helps with that.
Sure, sure. I think these are like iterative. Some of the things, there will be some hallucination when any new model comes along, and iteratively they'll just improve it and make sure that they solve the corner case.
Also, one of the like I don't know if it's still an issue, but one of the issues with like where GPT was in its 3 series or something like that. If you would ask it to rewrite the entire code, it wouldn't do that no matter what. It would just give you a placeholder for the previous code and it would just write the new updated parts of the code. Like even if you explicitly say like rewrite this entire code for me, it wouldn't do that. It would just give you like a placeholder and just add a new function to the old code.
Okay, so
AI
let's
gives you
watch.
an incorrect answer, and it's a big challenge with current AI models. But I've noticed that R1 is particularly good at understanding why it hallucinates, almost as if it's truly self-aware, and then it also corrects itself. So I started recording this specific clip here when I noticed that it gave me an incorrect answer to the vague question of what happened to Hershey's in 1998. It says Hershey's launched Almond Kisses in 1988, when in reality they were actually launched in 1990. So I pointed out the mistake and asked why it made the mistake. Because of its chain of thought approach, it's fascinating to see it run a search on this mistake, confirming why it made a mistake, and then it corrects itself here. Compared to other AI models, DeepSeek R1 thinks way more naturally, almost human-like, and elaborates on its mistake clearly, so I highly recommend challenging R1 when it hallucinates and give this a go yourself. It does seem to be slower though than ChatGPT 4o, especially when it comes to coding tasks. I've been playing around with
That's about it with respect to hallucination.
Yeah, I think another thing that I wanted to show you guys, which I mean, I used OpenAI for some query, and it fascinated me that it gave wrong answers, but it gave wrong answers in a very confident tone, as if it's getting the right answer. Like, for example, if you ask them to some obscure, I won't say obscure, but let's say some classical poem, and you want the poem to be, you want OpenAI to discover. Let's do that if possible. You have OpenAI tab open. So, for example, can you say David Thorburn, Thorburn? Uh, oh, no. I think John Crow. No, can you delete that? John Crow, Crowe. His John Crow Ransom, Ransome. And his poem is Captain Carpenter.
That's the prompt.
No, just say John Crow Ransom's poem, Captain Carpenter. Wait, can you write the poem? Yeah, this is all fine.
Okay, I'll ask it to write.
Can you give me the actual stanzas?
Pretty strong words for a poem.
Okay. I'll tell you the funny part. How many stanzas are there? Can you give stanza-wise analysis? Why don't you write that? Wait. See, this is what I'm saying. I think it's giving all the wrong answers. The actual poem is about 13 stanzas, but it will probably tell you it's 6 stanzas, and it will mix up some of the stanzas, and it will give you some obscure thing which is not even there in the poem. Okay, but it will make you think this is the actual poem. Wait, how many stanzas is it? Can you scroll down all the way?
It says that there's 5. Okay.
Yeah, see, I'm telling you, right? So when it gives this answer with such confidence, and this is a factual thing, you can actually check in somebody's textbook. It has like 13. I have this paragraph, poem in front of me, and it clearly has like 13 stanzas, and it gives you 5. And some of the times, what it does is it makes up stories on the go. Let's say it wants to say something bad about the character. It just makes up stuff, which is not even there in the poem, which for a young person who is supposed to write this for an exam, and if they write this, I think it'll be horrible. So always verify the answers. Well, for example, stanza 3, he had 2 wounds that had to bleed. Of course, there's nothing like that in the poem. Okay, it just made that up on the go. 2 wounds that had to bleed symbolize visible physical injuries. One that would never. Yeah. There's nothing like that. So this stanza 4 is non-existent. It just made it up on the fly. So what it's saying is, so this show, this is a factual thing. There is no subjective. You just have to take it from somewhere and reproduce it, and it's not able to do it because it answers every question. So what I'm trying to say is it answers every question like this. So it thinks what might be approximately true and approximates every answer. So if it is doing it in math problems, so you can imagine the problems that will come about. Once in a while, they'll get all the right. So for first answer is pretty correct. After
Mhm.
that, it's all junk.
So,
So
what if we write the same prompt in DeepSeek R1?
that's what I wanted to check.
We
If
can
anybody
check
Yeah.
it
can,
out.
do you have DeepSeek?
Yeah.
Okay, so let's do the same thing because it's factual. It's not like math or whatever. John Crow ransoms. Because this is not a
Just to be fair,
subjectivity.
I'm gonna turn off the search feature off. Let's just see. Do you want me to use the V3 model or the R1 model?
Yeah, let's use anything for now.
Okay.
Let's use the simplest one to the most complicated one. Yeah, the first paragraph is correct. Second one is not. Flourishing virgins with lovely young. That's non-existent. It's making stuff up. See, I'm just telling you. I think
Same.
what I think it's doing, it's taking answers from OpenAI,
Okay.
and I think because this is not even there. The second paragraph was it was a pretty lady and all her train that played with him so sweetly, but before, and now she had taken a sword with all her mane and twined him off his nose forever. But that's not what it says. So they took his sword, they took his bow. It's just making stuff up. So what did we discover from OpenAI? So how many stanzas? That'll be like an interesting.
I, the stanzas are completely different. It's talking about a surgeon and a herbalist in ChatGPT, and here it says about flourishing virgins and whatnot.
How many stanzas did DeepSeek give?
The
DeepSeek
actual
gave me
stanzas are 13, and none of the models gave the correct answer.
this one gave 14,
The
15,
14.
15 stanzas. Okay.
Okay, so what's the
15
last
to
paragraph?
It says
The
Captain
last one.
Carpenter rose up in his shroud and he swore that he would never ride again.
The rose up in his shroud, and he swore that he would never ride again, but he went riding out in his last cloud with a different lady and a different pain. That is not the last paragraph.
So it's just making
Okay.
its own poem, I guess.
It's just making its own stuff. What I'm trying to say here is this is a factual thing. So this is exactly how it answers all the other questions. So it thinks approximately true, but the theme of this Captain Carpenter is an anti-protagonist poem. Okay, it's about a man's search for meaning and how he is not able to do all the things that he had planned and all his failures. He just recounts all of them. The theme is correct, but it's not giving the actual thing. So the actual theme is correct. So what I'm trying to say is OpenAI, DeepSeek, all these models get the theme right, but the content is completely, it just makes things up as we go along. And this is like it takes some standard form and ask it, it'll give you whatever it thinks is correct.
Even
Pretty
I
neat.
so
experienced a similar thing in math while I was doing our research. So when I was asked it to give me some unimodular matrices, it went on giving me matrices whose determinant is not -1 or 1. So it went on giving me the determinants like other than 1, like 2 or 3, something like that.
I think the last time I gave you that, I asked that problem in the class, right? Wherein I gave you, so I gave the same problem. It gave me a wrong answer, even though the eventual answer is correct, but the intermediate step is wrong. So that means what? It's just copying from somewhere and it is approximating. I don't think it's even doing what human beings do. It's just doing some copying.
But
copy
when it
this,
comes
copy
to
that.
math, I guess DeepSeek has better performance metric than openAI models.
I think the
Yeah,
way the
that's what
upload,
they.
I
So
think the
let's
way,
look at the other. I mean, this is fine. I just wanted to show you guys how this was so bizarre. Actually, there was a poetry event, and I went and I used OpenAI because I couldn't read all the poems. So there were like 10 poems to read. So I'm not going to read all of it. So let's give all the poem names. And I realized the actual poem is completely different than the actual, the poem that OpenAI described. So it's always scary if you're not read the book and if you're using OpenAI to go to a book meet, you're gonna have some issues. Yeah. So we can go to another uh, feature of DeepSeek.
is what we saw. I don't know what Grok is though.
Grok is, I
Is it
think,
like
is
Open
it like
Llama?
X's? Is it like Elon Musk model?
I'm not sure. I think
I
it,
think Elon Musk AI model is called a Grok, GROQ.
okay. Well then, okay, okay.
Okay, Grok and Elon Musk. Just can you type? I think I thought.
Okay.
Oh, Elon Musk says GROK. And this is GROQ.
I think
Something
it is
else.
like Open Llama, which it's like Perplexity, but you can use it on your laptop to run distilled models of uh, DeepSeek or like GPT 4.0 or whatever that is.
Okay, can we go to the next one, next feature?
And this one's pretty funny.
Beyond the current scope. So it's basically not naming the current leader.
I think it like it processes through that chain of thought and realizes its mistake and
Yeah.
completely hides the answer or something.
Oh, okay, okay. This is nice. Can we watch this video? It nailed the hard math problem. What's the hard math problem?
Okay, I think this is the problem.
You can play it.
This is the chain of thought, I guess.
Okay. Peak memory is 4.5 GB. Oh, not for this problem, right? I think it's overall. Or the local memory, maybe. Yeah, can we take a look at something else? The next feature.
It's more of a bug. You want me to play this?
Yeah, sure. You can just play it quickly.
So these examples are all videos where it shows that it is learning from its mistakes. I saw in the previous question as well that, oh, this is not the way you're supposed to do this question. I'll go back, I'll backtrack and start again.
Yeah, but I think they've programmed this. I mean, this is not that hard to program, right? You just intentionally make let's say the first approximation, which is a huge mistake from the solution, and then you backtrack. So it gives the feeling of a human being correcting its mistake. But I'm pretty sure the reinforcement learning is doing the trick here. Okay, this is distillation from llama. I need to.
Isn't just about speed. It's about privacy, power, and precision. Here's a real-world challenge. A jacket costs $80. There's a 15% discount, followed by an extra 10% at checkout. What's the total? DeepSeek R1, Distill Llama 8B on private LLM breaks it down effortlessly. This is AI running locally on an iPhone, solving complex math in seconds. Local AI isn't just about speed. It's about privacy, power, and precision. Welcome to the next era of on-device AI. It's reasoning through each step logically, just like you would. And all of this is happening locally on an iPhone without relying on the cloud. OmniQuant is a game changer when it comes to AI model performance. The result? Superior accuracy, faster processing, and better handling of complex tasks. It's the key to making models like DeepSeek R1 run so smoothly, even on an iPhone.
I think it's a detailed calculator with multiple steps and stuff.
Yeah, this is like the
It's
thing
not
I mentioned,
but
OpenLlama, but for iPhone, I guess.
can you scroll down? I mean, this is fine. The NASDAQ news. Can we check this?
Okay, you can now use R1 on Code GPT, I guess. That's what this is about. Okay,
I'm trying to understand the classes and what it's able to generate the code. This is the code divided. You can go. You can go. I think this is code generation example.
okay, this one seems
Which is
interesting.
like code generation is good, but I think it's giving you templates. If you can see, it's mostly templates of like it will get the class name right, and it won't give you the broader details. But even if it gives the broader details, these are not like something that will replace a programmer's actual work. Let me play this.
I guess they're exploring the web search feature of R1 or something like that.
Yep.
Because this news is pretty new.
This is new, right? Comparison with Nazi symbolism. Yeah. Which is interesting. The app search, I think that's another company, I suppose. Got it. Oh, this is nice. We can wind up. I mean, we have like some more things to. So basically, they've come up with this group relative policy optimization. This is like a reinforcement learning framework. And as you can see, in this framework, you have basically an objective function that you're trying to minimize in some meaningful way. So So just to understand this objective function, this equation 1 of the R1 paper, and let's say the equation 3 of the R1 paper, can we go to that? This is the objective function. This is what is called the objective function plus the Lagrangian, right? Beta is the Lagrangian, and the constraint is the KL divergence of pi beta to pi reference. Pi reference is pi sub theta old to. So what it's trying to say, there are two probabilities here, and it wants the constraint to be the distance between the two distributions. And the way you measure the distance between two distributions, you do what is called KL divergence, as opposed to Euclidean distance or Wasserstein. You can also do Wasserstein distance. You can do what is called an optimal transport, but they do KL divergence because KL divergence doesn't have any units as opposed to Euclidean distance. So it's basically a notional value of the difference between the original probability value or distribution value to, let's say, the empirical distribution value that you would compute. That is the constraint. And whatever is the constraint, you add that to the objective function with a Lagrangian beta here. Okay, this is how, if you don't know anything about optimization, there is always a function that you want to minimize or maximize. And then you minimize or maximize that function with respect to some constraint. And then what you do, you use both of them, the objective function minimization is a dual of, let's say, working with the penalties when you assign the Lagrangian with respect to some constraint. So you add the constraint on, and that solving that constraint laden objective function is equivalent to just barely minimizing the objective function without the constraint. That's the broader idea of all optimization techniques. So if you go to what I've written down, yeah, so what I think this first function on the left-hand side that you can see is, can you move the cursor so that like I can't? Yeah, so this basically is like the objective function, which is, again, to understand this, you go to the second page of the previous one. Yeah, the policy gradient is basically, so here you're getting a gradient function wherein it's gradient of log of the probability of an action with the advantage given the state, action given the state multiplied by the advantage function. Okay, so advantage is, so in reinforcement learning, the whole idea is you come up with a policy function, and the policy is the real life experience of an actual agent, and the agent's the agent's, let's say, essence is to optimize the policy function to its benefit. As soon as the advantage becomes negative, it will stop doing that action. It will go back to other actions in the class of actions where its advantage function is positive. Okay, so the loss function that he takes into account is the loss function that I've written here. The expected value of log of, let's say, this probability value multiplied this probability value of action AT given state ST multiplied with advantage AT. Okay, the cap has got to do with the fact that these are all empirical values. Is every time there is a cap in any of the formulas, it basically means that you're taking a bunch of samples. In this particular case, T, let's say samples with respect to T, and you're taking those samples and you're actually computing the average. Okay, and when you differentiate this, basically it's 1 by, whenever you have log x, it's 1 by x is the differentiated form. And then the chain rule essentially tells you that you 1 by the probability function, and then you multiply that with the differentiation of the actual thing which comes on top. So when you differentiate the loss function, you get a gradient function which is equivalent to the gradient, which is equivalent to the policy gradient that we had at the beginning. Okay, and if we go to the next page, So essentially what he's trying to say is, so here he is trying to say that even if you have log of probability function which is computed, this is equivalent to ratio of probabilities, wherein phi sub theta is the new action that you take as a result of your first step, and pi theta old, it's actually theta that is missing here, pi sub theta old theta, which is the previous, let's say, policy function, and the policy function changes after every step. Okay, and the action functions are essentially action, or let's say state actions are 80. So every time you go from one state to another, you compute the policy function all over again and make sure that it is your overall direction is positive, meaning like you're optimizing your let's say you're optimizing whatever you're optimizing for. Let's say you're optimizing for food or you're optimizing for money. You do the action and you count how much money you had previously and how much money you have now, something on those lines. So here, basically, I've written what happens if you take a gradient of a log ft. This is again example explanation of what I did in the last step, wherein you take a gradient is differentiating a function. And if you differentiate a function, it's 1 by f of theta, and then you differentiate the individual function on top. So here, what it's also saying on the right hand side of this is that you sample from the old. This is the thing that I usually tell you in any class or any place I meet anybody. I have to explain something about probability. Probability has got to do with conducting random experiments. In those random experiments, there is, let's say, coin toss. You do 2 coin tosses, and your job as part of the sampling exercise is to generate the samples without actually having the coin. So assume that theta old is one of the coins which generates some sequences, and your job is to come up with an action sequence, which is another sample, which is not from the same sample, but from a different distribution. And your job is to be as close as possible from the first distribution. You don't want to go too far. Another thing that I wanted to explain here, if you go to the next, I haven't have I written anything in the next. Oh yeah. So this is where so the objective function is what you see here. You want to maximize the expected value of this ratio of probabilities, phi theta and pi old theta. So pi theta old is the old policy function. Pi theta is the new policy function after taking a step, right? So every time you go from 1 to 2, you take the policy function ratio of 1 with the numerator 2 by 1. So you take another step, you compute the policy function again. And then, as I pointed out, the term written in red is the objective function, and the term written in the black ink is the constraint. So if you go back to the actual R1 paper, can you go back to the R1 paper? Keep this and go back to. So if you look at what these people have done, this is essentially the same thing I've written there. So it's a ratio. You're minimizing an objective function as a ratio of probabilities, and you're constraining it with a KL divergence, which essentially says that you're not going too far away from your original probability. And the reason they do it, can you go back to what I've written? Yeah, so can you go back to the next slide? We'll come back again. Have I written anything in the next slide?
This is the final one.
Oh, there was one more slide. I didn't write anything there. So can you go Google trust region policy optimization? Or you can just type it on Google. I mean, we won't get into all the technicals, but basically what it's doing. Yeah, this is the main paper on which this whole reinforcement learning work is built on. And I think he's in OpenAI, or he was in Berkeley, but John Schulman, he's quoted a lot in the R1 paper. He graduated from Berkeley and he started working in OpenAI. So when people say, "Oh, this R1 paper is completely upended OpenAI's work," he's the inventor of the main method that is getting used in R1 paper, and even R1 paper people refer to that. So his main technique is what we call trust region policy optimization, right? TRPO. I think it's in the second half. Do you see TRPO? Yeah. So he's got an entire derivation and entire paper on this. And also Michael Jordan is listed in this. So he's like the godfather of, let's say, all of machine learning for the last 30 years. I think he must have done his PhD under him. Yeah, are you guys familiar with Jordan at all? But
No.
he's the Michael Jordan of machine learning, so to speak, like the way Michael Jordan.
Okay, that's a good way.
Okay, so can we go back to the, or in this paper, can we scroll now? Do we have? I wanted a diagram, if it is available.
This one?
No, I don't think it's there here. Here, okay, in this preliminaries, right after the paper, they write some derivations, right?
This one?
Yeah. So before this, yeah. So I think somewhere he explains. Probably we can explain it some other time. So this Shyam Kakde's paper, which is 2002, which is also a good paper. All this is basically you can look at numerical optimization, and there's a very popular reference numerical optimization. What's the famous book? Wait, let me tell you the.
This one?
Probably we can put the name of the book in the references. But the point here I'm trying to make is if you can, in usual gradient descent algorithm, you have a policy function, and if you optimize in the direction of the gradient, you optimize as much as possible. In this particular algorithm, you cannot do that. If you do that, you go far away from the actual objective function. So what they do is they ensure that you only go in the direction within the trust region. So that's why there's a constraint. So you want to optimize in the direction of the gradient, but you don't want to go all the way and exhaust everything that you need to optimize. That's why the constraint here is you need to go in the direction of the gradient, but you don't go far away in the trust region. That's why there's a constraint in terms of how far you can go, and that constraint is captured by the KL divergence. And the usual technique of in optimization is you have an objective function and you have a constraint, and you use this what it's basically saying is the last line that I've written, right? The optimality point of let's say the constraint problem is also an optimality point of beta. So meaning solving what's in red is equivalent to solving the combined problem. Okay, so this is how they use let's say this is a way by which they can solve this problem by using what is called a penalty problem, meaning like you can so what it means is if you go too far away, you can penalize that function to a point wherein it comes back within the trust region. That's what this essentially means. So broader idea of, let's say, people who are not familiar with optimization, solving what's in red is equivalent to solving the combined red and black, which is there in the third equation. So if you compare the third equation with 3 in the R1 paper, it's pretty much the same. Okay. And they have come up with an interesting method to solve it. As as has John Schulman's paper in 2017, 2018. Okay, that's the technical stuff of R1.
So that's all the content we have for today.
Okay, so can we go back to the last slide of so, and these are like some of the benchmarks that they have. You can probably play this and we can wind up with that.
Yeah, this is the same video that we played, so it's fine.
Oh, it's the same video. So, and these are like the benchmarks that the DeepSeek has done with OpenAI.
Yeah.
Okay. Can we
The
go
on-
to,
the
is this
only
the last
thing-
slide?
Yeah, this is the last slide. I think the only thing where R1 kind of is worse than OpenAI is the GPQA diamond. I think in the first few podcasts we discussed what GPQA diamond was.
You
So-
want to recapture that for like in a line or two?
Yeah, so GPQA diamond. So these are all, so whatever those names that you saw in these tables are, they're all benchmarks. So these are benchmarks, not necessarily just for LLMs, but MMLU is for LLMs, and all of these others are for like human and LLM. But GPQA Diamond, it's like really hard math questions and all of that.
Oh, that's great. So I think we can probably take a look at it some other time. So
Yeah.
I think that's pretty much it for this week. This week was the entire news was about DeepSeek and its impact to our natural world. And hopefully we will have more updations in terms of the updations that are there in the world of AI. And anything that you as viewers, if you encounter something, please leave in the comment section what you think we should cover. We'll probably do it in the next session. Thanks, Dan, for joining. See you next week.